Go. All right, so we went for part C where we wanted to find the time above 300 to where there was no people in line. And so we basically had to set up this. So for part C, we took the initial amount of people in line because we can't forget those guys, all right? And then we added the integral from 300 up to some time of the amount of people entering the escalator minus the amount of people exiting. Remember, you had rate of people going in, which is this originally function right here. This is the rate going in, right? Where R of t is measured in people per second and whatever, okay? And that's people entering the line for the escalator. Yeah, Z. What's that? My bad, 80, yep. Yeah, we figured that out from part B. Yep. So you got the number of people at 300, okay? And then now we're doing past 300. And when you get all this done and so forth, you basically set that equal to 0. And we basically get time equals 414.286. Okay, so 414 seconds, that's when no people were in line. All right, then part D, what we're talking about is between 0 and 300, at what time t is the number of people aligned the minimum. Okay, so we're looking for absolute min. All right, and so we have to not only test. All right, so let's get our equation for part D. So we have a function, right? And our function's representing the initial one, 20 people. Between 0 and t, I don't know. T is going to be between 0 and 300. I don't know how much it is. All right? And the rate of people coming on minus the rate coming off. So that's the setup for D. That's our function. Now, how did we find max and mins? First derivative equal to 0. So I need to do f prime of t equal to 0. Well, here's f. So I need to differentiate this guy. What's the derivative of 20?
20x squared.
The derivative of 20 is just 0. We're differentiating, not integrating. Not integrating yet. I'm differentiating. I need f prime, guys. F prime. So I'm differentiating all this mess right here. Okay, so the derivative of 20 is 0. And now, what's the derivative of the integral?
It's what it is inside.
It's what it is. Okay, so it's really just r of t minus 0.7. Okay, remember this rule. The integral from 0 to x of f of t is just f of x. Okay? You just literally plug in that thing. They cancel each other out. Okay, the derivative of x squared is 2x. The integral of 2 is back to x squared. Okay? All right, so now we know what f prime is, and now what we're going to do is simply set that equal to 0. We're going to take all that and set it equal to 0. All right, let's see if I can figure out how to type this in. All right, so turn it on here. All right, can y'all see that screen? If you kind of a little bit, okay. So I'm sure if we all crowded in up here, we could see it. All right, let's go type this in. All right, this is, let's see if I can type it in right. So I've got it up here. Okay, and I need to solve it. Now there's a function here. If you look under, clear. Or escape. If you go up under F2 algebra, now I'm on 89, but you're going to have to figure out on your calculator, there's a solver, okay? And you can plug that in, and my function is basically R of t, which is this guy. Now I'm going to copy that in and then erase some things. I don't need everything. So there's my function. All right, I'll end it. It's that, and let me get rid of the beginning part. Whoops. I apologize because this is not easy to do. All right, so I don't need the integral. Okay, so I'm going to get rid of that. Solve that.
So you're not doing the integral of 44.
No, the derivative of the integral, this is what f prime is, just r of t minus 0.7. Remember, the integral of r is just r of the top number. Okay? So let me see if I did this right. Nope. Escape. I got to put in equal to 0. Too few arguments. Oh, I forgot to tell it it's in terms of t. So you do comma t. Yeah, I got a busy. Busy means it's working. All right, these take a while. We have to wait for the answer. What?
What'd you put the answer in the equation?
So I put r of t, which is
That RT, which is 44.
yes, the original equation given in the problem. That's r of t. So it's just that minus 0.7. That is f prime. Okay?
That's what I thought it was.
Yep. So we plugged it in, and I used the solver while I'm. Does this work? Oh, no, it's not working.
I couldn't say like 270.
All right, hold on. I've got it working now. So the syntax for typing this thing in while we're still waiting, you type in solve, parentheses, you put your function equal to whatever you want. You could put in a number, whatever. I need it to equal to 0, right? And then you do comma x or comma t. That's the syntax, how you type it in. All right, so I typed in f prime. I typed in this, r of t minus 0.7, comma t, solve. Okay, there we go. We got our answers. Okay, so let me blow this up here a little bit. Emulator options, to view. Yep, so I literally just typed it in, solve. Look right here, solve. I put my whole function in. Let me highlight it. Minus 0.7 equal to 0, and in terms of t. Okay, so that's all I typed in, and it gave me the two answers, 166.575 and 33.013. So remember, to find absolute, it's what? First derivative equal to 0. First derivative equal to 0, and the endpoints. Don't ever forget, absolute is endpoints as well. So here we go. So I got to make a chart here. So I've got time and f of t. So I've got 0, 33, quiet guys, 0, 1, 3, 3, and then 166.575, and then 300. All right, so now I need to evaluate f of t. Well, f of t is what? This guy right here. So let's plug that in. All right, so you're confused?
Yeah.
Stop me then. Stop. What's going on? How did I get what?
The answer.
All right, so I typed in.
I only got 0.
So if you typed in solve, parentheses, the equation equals 0. I know it might be under algebra or math.
I think it's under math B solver. Math.
Yeah. Do you have an 84?
Yeah.
Yeah. Anybody, 84 experts in here?
I'm 84.
George knows 84s. George, how do you use a solver?
How do you solve the equation? George, how would you work this on the 84?
You go to a math, you go to math,
Okay.
and then there's
Oh, while he's doing that, you can always find every function under catalog.
you
All right.
go to math, and then at the very bottom there's a numeric solver. Go into it. You can enter two sides of the equation.
So I just, and yeah.
This for the variable, the x, t, theta, and for t variable. And then you press, I can't show
So
it.
is equation
Cancel.
1
Hold on.
one side is equal to?
I think I have an 84 in here. Let me find it.
Okay.
It's
So, math, and then solve. Oh, you have the old one. That's okay. The old one you have to set it equal to 0.
Right.
And then you use this for variable. For example, yes, usually the older one doesn't work as well because you have to set the equation to the zero. And then after the newer one, you have to set the equation to the zero. But the newer one, you can enter both sides of the equation. And then when you finish,
I thought I had an 84 ROM.
this is for like simple math, I guess. It's not very practical to use this. So, and when you're done, you go in there and you.
Is an 83 kind of the same as an 84? I have an 83. I'm trying to find. I had an 84, but.
No, I'm only getting the answer 43.01.
So let's say.
You're not getting both?
I'm not getting the other one.
So.
Can you hit next? Is there like an arrow?
So that would be
And
this
when
one.
you yeah.
You have to guess.
And then when you're in there, you
Yikes.
enter like a guess. If there's like two or more solutions, you enter like a guess.
Oh, George. Yeah, George is saying you have to kind of type in a guess. So maybe type in a number above. See, I don't know how you would know to do that.
Give you the closest one.
Yeah.
And then you press alpha.
Yeah.
And then solve.
Who told you to get the 84?
Miss Lockwood.
At the beginning of this class?
Yeah. It was like the only. It was the one that she like really wanted.
Who has an Inspire?
I do.
Does it actually give you both solutions on the Inspire? Kanto, find.
But then I returned it.
89 ding.
Does it give you both?
Yeah.
Yep. See, the Inspire and the 89 gives you both answers.
Yeah, we're like 89. Yeah, like look at ours.
Yeah.
Do you use the Inspire in exam?
Yes.
That's my really? I want that.
All right, guys. I apologize.
We're scammed by the
That'll be my mission this spring break. I have an 84 somewhere. I will figure out how to get multiple solutions easily without you having to guess. All right, but I want to keep going because I want to at least get through problem 2 today. All right, guys. So we've got. All right, I need everyone's attention here. So we found these solutions. These are my endpoints, 0 and 300, and then I found 2 times, 33 and 166. So now what I need to do is find what f of t is on that. Well, f of t is this original function here. Okay, so really what I'm doing is I'm going to find the integral. So let's go integrate. See if I don't mess this up. Enter. Now I need to type in, I'm going to do the integral of rx minus 7. So let's do this guy right here. I'm going to copy that in.
Could we graph that and just do it?
You could. There's always graphing by, yeah, but it's kind of hard to graph the integral.
Oh,
Okay, that's the problem.
I mean, we can just do the integral and then get the graph, the result.
Yeah, so anyway, it's comma, and it's 0 to comma. I'm typing in the first one, which is, hold on. This is really slowing my computer down. All right, 33.0133, and I think that'll be fine. All right, hold on, I got to get rid of something here. Whoops. Because I copied it in. I don't need the solve part. All right, so boom, 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 boom. All right, so solve the integral of that. Minus 0.7 t to 0. Okay, let's see what we get here. All right, so then I get negative 16, but remember I have to add 20. So I get 3.80344. That's what I get for plugging 33 into f of t. And remember, f of t is this guy right here. All right, you just got to remember to add 20 in to the integral. All right, let's repeat that thing.
Once we learn how to do the calculator over spring break, can we come back and redo this?
Yes, absolutely. So this one is now, instead of from 0 to 33, I need to put in 166.575. Enter. This one's 138. Add 20. Don't forget to add the 20 on. So I get 158.07. All right, now 0, what's the integral of 0 to 0? 0. So this is just going to be 0 plus 20. So 0, we can just do that in our head, right? Because the integral from 0 to 0 is just going to be 0. All right, now let's do 300. And I'm going to change that last number to 300. 0 to 300. I get 60 plus 20. We already knew that from previous. That's 80. All right, which one's the smallest value?
0.
No. 33.0133. You get 3.8. Okay? So how do you interpret that? At time 33 seconds, there are approximately 4 people. 3.8 people. Okay? So they say to round 4 people. Does that make sense?
There's only 4 people on the escalator.
That's the least amount of people. It occurs at 33 seconds into this whole mess. There's the ultimate min. Okay?
I didn't.
All right? So the idea is the hardest part of this whole equation, this whole problem, was setting it up. All right? Now, always remember, when you're trying to add up things, it's integration. That you got to think integration. If I'm adding things up, it's integration. And we're just adding up all the people. That's the rate at which they're piling on the escalator. Okay? All right. We'll come back and we'll redo some of these. I'll see if I can find a similar one to this. All right? But let's go ahead and jump into number 2. Now, I found 2 to be kind of easy. And so, like I was mentioning, this is the one we want to not miss. Okay? So let's talk about this. All right? A particle moves along the x-axis given by this velocity. So we have a velocity of the first particle. It's this guy, between 0 and 3.5. The particle the particle at time equals 0 is at -5. So that's its initial position. Okay? Part A. Find the acceleration of the particle at time equals 3. Derivative at a point. All right? And so really, remember, it goes like this. Position, velocity, acceleration. And when you're going down, it's differentiating. If you're going back up, it's integrating. Okay? So I need to get acceleration. And to get from velocity to acceleration, we differentiate. So really what I'm doing, I'm just doing v prime of t at what? At time equals 3. The calculator does this automatically here. So let's do this. I'm going to experiment with something. And there's a cool function called define. I like using it. I'm going to go to F4 on my calculator. I hit 1, define. Sorry, I got to slide up and down. I'm doing it so y'all can see. And I'm going to define v of t. So I'm going to go alpha v of t is equal to, and now I'm going to type in that whole mess. I'm going to type, abuse your parentheses, by the way, 10 sine. I don't know where it is on 80 Inspire. You're going to have to find. Worst case scenario, guys, go into catalog. Catalog, and then I think if you hit a letter, it'll jump down to the D's.
Yeah, into alpha letter.
Okay. So 10 sine of 0.4. Now I don't even know if this is going to work because I don't want to have to type this function in every time. So if I can just define v of t to be that, then I can just say differentiate v of t. Okay. That divided by, start a new parentheses. I need another parentheses right here. Okay, and then t squared minus t plus 3. Okay, let's see if that works. Of course it doesn't. Syntax. Now I'm just trying to define v of t equals. Did I forget the equal sign? No, define v of t is equal to, I need one more parentheses here. V of t equals, there we go, let's see if that works. Bam, okay. So what that does for me now is I can just do v of a number. I can just plug in v of 5 and get You know, you see what I'm saying? I can do like f of a number, like function notation. All right, here we go. I'm going to go F3. I'm going to go to differentiate. I want the derivative, so I'm going to hit that, enter. And instead of typing the whole function in, I get to just do this now, v of t. And what you do v of t, comma t, like this. All right, so what this is saying is I'm going to differentiate v with respect to t. And then to plug in a number, you put this bar. At least, again, I know how to do this on the 89. And then you just say t equals 3.
They don't have to define on the, they don't have to define on the 84.
Well, they're going to have another way. So here's what my goal is for you guys. I've got this worksheet. You're going to have to do some YouTubing and Googling here. But I'm going to give you this sheet, and I'm going to say, figure out how to define a function to a variable. We'll come back, and you can always retry. You don't have to do this define thing, guys. The define thing is just me for shortcuts. I don't want to have to type it in every time. So look what I did. Instead of having it, you could have done derivative. You could have typed in the whole function, comma t, and then bar t equals 3. But I don't want to type it in anymore. So now from here on out in the rest of the problem, I can just do v of t. Okay? All right, so you can see we get at that time, we get negative 2.1182. Okay, so that's the acceleration at time equals 3, derivative at a point. Now, being it's a calculated question, that's why they chose such an ugly function. You don't know how to integrate. You could have differentiated that, but oh my gosh, it would have been horrible. Okay? Yes?
I don't see why I'm not getting that, but I'm getting this. I don't see.
You got to put your bar in. I don't. Oh, you did. I did. So derivative 10 sine. Yeah, I don't know.
Is there any way to go back to what?
I don't know. Are you in degree mode?
That's probably it.
Put it in radian mode.
No, that's why. What that?
Always be in radian mode because calculus just works better in radian mode. Things are just definitions are based off being in radian mode. See if you can get that. So those who are listening, if you have an Inspire, make sure your calculator's in radian mode. Do that and then redo it.
Would they accept this answer?
No.
Really?
Yeah, because I'm looking for what is the acceleration at that time. Well, it's not 0.000 whatever. It is negative 2 point. What does negative mean? Direction. Remember, velocity and acceleration are generally direction. All right, here we go. Part B. Find the position of the particle at time equals 3. Integrate. All right, so watch. I'm going to go up to F3. Instead of differentiate, I'm going down to integrate. All right, and then instead of typing the whole function in again, I can just type in v of t, comma t, and you just do comma 0, comma 3, between 0 and 3. Yeah, I've already defined what v of t is. Okay. Now remember, the answer I get, is that going to be my final answer? No, because what's the original position? At time equals 0, it already has an initial position of negative 5. So, all right, so I got 3.2397, right? So there's my integral right here. So now I just simply say minus 5. That's the answer. Negative 1.76021. Does that make sense? Okay, so I had to find the position between 0 and 3, all right, at time equals 3. But that's just from 0 to 3. It has an initial position of negative 5, so I have to consider that. Okay, so I just took my answer and subtracted 5. All right, part C. Oh, I'm sorry.
I don't exactly know how you type it in.
Oh, all I did was I typed in integral of, let me copy that in. You can see the syntax down here because when you copy it, it's the integral of the function, comma, variable, comma, 0 to 3. And I could have just done I could have just done it all like this in one shot. and then subtracted 5. So I could have just typed it all in one shot. And it'll give you the negative 1.76 right off the bat. You don't have to do it twice. Okay? So it's the integral between 0 and 3, and then you subtract 5, which is the initial position. Yeah, see? You get the same thing. Okay?
Oh, I got 3.23. Oh, I see what you did.
Yeah, you get 3.23. That's just the integral. Now just subtract 5. And then you'll get the negative 1.7. All right, let's look at the next one, and let's try to analyze this. And this is going to be very crucial for you to understand some things. I need really everyone focusing on this next part. Evaluate the integral of the velocity between 0 and 3.5, and then evaluate the same integral, 0 to 3.5, of the absolute value of the velocity. Interpret the meaning of each integral in the context of the problem. So let's see if I can lead you into this. V is what? V is velocity of that object. Okay? When you get stuck, and let's say you're just like, you're lost, okay? And you're like, I don't understand what they're saying. Graph it. Get a picture of it. So I'm going to graph it, and let's just see what this even means here, okay? I don't even know if this is going to work on I want to use Desmos, but I'm going to try and do this. Green diamond F1. So let's go here, clear, clear, clear. All right, and I'm going to let my function be v of t. See if that works. Enter. Okay, now I'm going to do zoom. Let me just try zoom decimal and see what that looks like. I'm probably going to have to do zoom trig. Yeah, I was afraid of that. Escape. Zoom trig. Let's try 7. All right, undefined variable. So it's going to make me type in the whole thing. Escape. Sorry, keep on thinking it's a touch calculator. All right, so let's go home. I'm going to type in alpha v of t and enter. So there it is. Now what I'm going to do is I'm going to highlight it, and then you can go to F1 and copy.
Oh, yeah.
There's a cut, copy, paste tool. All right, now I'm going to go to green diamond F1, clear, and then now I'm going to paste it. F1, paste, 6. Enter. All right, so there, that was kind of an easy way. I had it in V. I didn't want to retype it again, but it doesn't seem to like, like V function notation. Now I'm going to hit zoom trig, 7. What? What is not?
So that's C.
Oh, it's T. Doggone it. That's why. I could have done V of X equals a function. It doesn't understand T. So, all right, let me jump over to Desmos. So that's why sometimes, be careful. If you need to graph, use X.
How do you highlight the whole thing?
I just use arrows. And just move your arrow around and it'll highlight. Again, that's on the... There we go. All right, so what I'm going to do is I'm going to put in the velocity equation. I need you to see something visually here. So this is what? Parentheses, 10. You know what? Let me use this calculator. 10. Function. Sine of 0.4. I'll have to use X because it doesn't have a... all right. And then I'm going to make that all divided. So, hold on. Boom. And then go here. So all that divided by, I'll use parentheses again, and this is going to be x squared minus x plus 3. All right, here we go. Let's look at this. So this is a graph visually representing that velocity. It's going from 0 to 3.5 right here. So remember, what does integrals do? Find area underneath curves. Do you see I have some area above and some area below. How would you interpret that from a physics point of view? Remember, this is velocity. What is that point right there? 0. So interpret that physically. Velocity is 0. So I've got a body moving, and what does positive and negative mean in velocity world? Direction. I have a positive direction basically, okay, and then my velocity stops, and now I change direction. So here's what integrating all the way from here. How would we figure this out? This wasn't a velocity equation, and I say find the area underneath the curve. What would you do? You would break it into 2 integrals, right? You would do 0 to here, and then you would do negative because it's below from here to here. Okay? But what happens if I integrate all the way from here to here?
It's gonna have a negative.
You're going to have an answer. What does that answer mean in relation to the absolute value? Now, instead of making your brains go nuts and wasting time, understand this. There's 2 types of ways of measuring things. There's displacement and then total distance traveled. You know they're not the same, correct?
Yes.
Yeah.
All right. If I'm moving from this blue square to that blue square, that's displacement. Okay, I'm staying in between the 2 blue squares. But total distance is going from here and adding that distance. It's one absolute value gives that one. Okay? So to interpret this question, we can find it. We're going to integrate this. All right? That the normal function between 0 and 3.5, that's just displacement. That is not the total distance traveled. Okay? Total distance would be absolute value. So
it flips that part up.
yes.
So then it's
Right. So burn this and tattoo this on your brain, okay? Integrating a normal function when you're dealing with velocity and position, that is just going to give you displacement. But if you do absolute value, that will handle in and give you total distance. Let's actually find the values. And guys, for those who are not here, I was pointing at the board, but you can see, hopefully you heard what I said in that graph. If you integrate just the function between two numbers 2 times, you don't know if it turns around in there. In fact, we could figure that out. We can figure out when velocity is equal to 0. All right? And in other words, you could take that initial function, set it equal to 0, and you will get this value right here. This value right here, let's look at it. 2.802, that's where this thing stops. That has a velocity of 0 right there. Okay? So what we're going to do is we're going to integrate between 0 and 3.5 of v of t. All right? And let's find that out. Let's go ahead and plug that in. I think I already have this in the memory somewhere. All right. Well, part of it. What did I do? There we go. On. Okay. Clear. Home. All right, so I'm going to go F3 calc. I'm going to integrate and alpha v of t, comma t, comma 0, comma 3.5. So let's see what answer we get. All right, so I'm integrating just the normal one. I'm just doing this guy right here. All right, hang on there for a minute. I know. So we're going to get a number, and then hopefully I can go quicker. All right, 2.84. That's just displacement. Now, if I go in here, I'm going to go into catalog, and I'm going to do absolute value. All right, alpha A. That's going to make me go all the way up. Hold on. Start packing up. Let me finish talking here. If you go into catalog, there's a function called ABS. All right, so I'm going to copy that in, ABS, put another parentheses in.
ABS is absolute value?
Absolute value of that. Enter. I get 1, 2, 3, 1, 2. See, absolute value. I got too many parentheses here. All right, boom, boom. Okay, so absolute value. Oh, it should be here, and it should be here. Absolute value of that. Oh, come on. What's going on? Integral?
Isn't it 2 at the interface? I don't think you need to.
Yeah, I don't think you need to.
Okay.
I think it's 101. No, it's saying
Oh, I see. I just need one there. Right there. There we go. All right, this is absolute value is going to be total distance traveled, and it should be a larger number. So it's like from here to here is 2.8, but from there to there, turning around and coming back, the absolute value will give us, I think I wrote it down, 3.737. So you can see that's total distance. All right, so that's the interpretation of what absolute value is. It's going to handle going all the way there and turning around and coming back. Calculator was so slow. Anyway,